Hello, welcome friends to Machine Learning Journey. This is lecture 3, and in this lecture we will mainly discuss about features and labels, what this terminology is in the machine learning. Before we start, let's quickly recap what we discussed in the lecture 1 and lecture 2. So, in the lecture 1, we mainly discussed about AI, ML, DL, GenAI, all these words. So AI is basically a system where you have a specific rule-based system or any intelligent system which try to make a decision as human do. In machine learning mainly plays with statics and mathematics. So when you make the system, if you have a rule-based system and then the system complexity increases with time, or in general if you want to make some system which can make a human like intelligence system decisions, then you need to write all the rules, and at one point the rules varies and increases. So with that kind of solving problems, you need some mathematics and statistics to identify the patterns in the data, historical data. So there machine learning comes. In the deep learning, mainly it is on the basis of neural networks where you have hidden layers, input layers and output layers. Mainly it's based on the complex data structure, or I would say mainly it is on the unstructured data, whereas audio or text or images or video, like that. Generative AI is also part, is a subset of deep learning where mainly thing is the text generation or image generation, where the new data gets generated on the basis of previous pattern or previous tokens. So all this we discussed in lecture 1. In lecture 2, we mainly discussed about the data, what are the types of data, what is bad data, what is good data, how important data is in the machine learning. So always remember the most important component in the machine learning training or making a model is data. Quality data with a simple algorithm can outperform a bad data with a complex algorithm. So the first thing is a quality data. In the data types, we discussed about numerical data, categorical data. In numerical data, we discussed about continuous and discrete. In categorical, we discussed about ordinal and nominal. Ordinal data are like hierarchy wise low, high, medium, or ratings. Nominal data is like name, for example, colors name or blood type name, A, B, B positive, like that. Now in this lecture we will discuss about features and labels. So it's a very common terminology used in. So let's say like the machine learning name itself says that machine learns something. So from where it learns? So from where it learns is it learns from data. So uh, inside the data, it consists both input also and output also, and the input output pairs, I would say. So input is named as features and output named as a labels. As of now, you keep in mind this. Now what is the feature? For example, you have a problem statement of predicting a house price. Now, what all input you need? Think about this. What all input you need? Or for example, you are going to buy a house. So what are the things you will consider? So you will consider whether it is a 1 BHK flat, 2 BHK, or whether it is a bungalow, like that, or a complete independent house. What is its location? What its a location? What is the area of the house? Likewise, the various things, or even you can also consider the environmental conditions, surroundings, uh, cost of living, cost of living. So all these factors you will consider. So all these factors are come under inputs for what? For to predict the price of your house, the house which you are going to buy. So these are the inputs. So this inputs is nothing but features in the machine learning, and the output, the price which it will be, let's say it is $10,000 or 1 CR or like that. So this price is label. So in the machine learning, whatever data set you have, in the data set itself, the one label will be output, or one feature will be output, which is a label, and the rest all will be input, which will be the features. So output will be label and input will be the features. So input here, many things will become as is bedroom, area, location, cost of living. So all these things will come, and the each row there will be one entry that 2 bedroom in Bangalore location with the area, particularly area Kormangla. What is the price of a house? So it will be filled here. Likewise, this is a complete table. So this complete table is a data, and the input features are this, which goes to the input, and this is known as features in machine learning, and the output is label. Now now we will understand about, like we have understood about house price prediction, where input are many features and outputs are labels. So let's say we will take one more example about spam detection in the email. In your email, there one model which always monitors the every incoming email, and it classifies into a spam or not spam. One is spam, one is not spam. So whenever the input email comes, so the what will be the input feature, or what will be the feature? Feature will be email content. So email content can be win 1 CR lottery. So this is the content of the email, and it is a spam clearly. So it will be marked as a spam. So spam is a label. And let's say, dear customer, please update your e-nomination or nomination in your bank account. So this is a complete valid mail. So it will be as a not spam. So like guys, this is are the input features. Input features are the text or email content, and the output is a label, which is a spam or not spam. Okay. So this is all about features and labels in the machine learning. There can be a multiple features in the house price prediction. We uh, took many features. So there can be a multiple features. In the spam classification, there is only one input feature, that is complete email content. And you have also heard about the feature vector in the machine learning or somewhere in the deep learning. So this is also very simple. It is a representation of some data. For example, if I say, let's say one image is there, cat image is there. So what this has is pixels, like pixels values, RGB channels are there. We will discuss in deep learning about RGB and channels of image. But as of now, let's understand there are some numbers uh, to represent the colors in the for an image of cat. Now these pixels are the in numbers, and these numbers, if I just flat it all the numbers into a one vector, it will be representation of this cat image, and it can be a feature vector also, because it represents the cat. Now in the deep learning, we modify this feature vector, we represent it into small dimensions. If it is of 2 to 4 cross 2 to 4, it will be very big. So instead of this much big, we assign it to some dimension of 768, some 264, something like that. We represent it into features. What is a feature vector? It is a float value or some numerical value, also integers, anything can be there. So this is a feature vector of a cat image, or anything which there can be a cat word also. For cat word token, corresponding embedding vector is also there. So this is also known as a feature vector, which is a numerical representation of an entity, whether it is a word, image, or any data, any real world data. It is a representation in numerical formats. That is a feature vector of that particular thing. Label vector same again. So spam, not spam. So you have 0, 1. So spam is 0, not spam is a 1. So that is a label vector, which is a output for output. Same as in the feature, images also work same, text also works same. Everything numerical representation of an entity. So features goes to the model X, which is represented as feature, and Y represented as the label. Features are output, labels are sorry, features are input, labels are output. Okay, so input X goes to model Y, which is output. This is the overall diagram or flow of data. So data is divided into two things. One is feature, one is labels. Feature as a in, label is output. Everything we will decide what will be the feature and what will be the label. The label which we want to predict or output. So like this we distribute. You might have heard about feature engineering. So feature engineering also is like how to combine features such that it is a best combination such that it can predict the output with good accuracy. So in that we apply some mathematics, we apply some reasoning, we understand the data patterns, and we apply some feature engineering. That is known as a feature engineering. So thanks a lot. In this video, mainly we discuss about features and labels. Features are the input and labels are the output. As of now, just keep in mind. In the next lecture, we will more understand more about this, and the mainly we will discuss about types of machine learning. There we will talk about supervised, unsupervised, semi-supervised, reinforcement learning. All these stuff we will discuss in the next lecture. Thanks a lot.